we'll create a surface model for a hull form. Seen here is a surface model of a traditional flat-bottom boat. The surface model consists of 4 different surfaces. A surface on the side, and then one on the bottom were first created. Then these surfaces were mirrored about the x-axis to form the other half. We'll start the tutorial by creating a principal enclosing box on the PEB layer. This is a box that defines the maximum dimensions of half of the hull form. So half of the hull form will just fit inside this principal enclosing box. Then I'll add data points on the points layer. I'll use these points to pass spline curves through that define the outer edges of the hull form. Here you see the spline. The data points needed to create this hull form are available on the spreadsheet file named Dory Offsets. At this point, I'll start a new metric file. Notice that I changed the background color. It's not necessary to do this, but to do so, right-click and select Options. In the Display tab, select Colors. Set the window element to Model tab Background. Then choose the color under the color heading. Apply and close, and select OK. Moving on, I'll select the Layer Manager button. I have already created the layers I will use, each with a different color. You may want to pause now and do this if you're following along. Now I'll make the PEB layer current and say OK. Then I'll switch to a southeast isometric view. First, I will create the principal enclosing box. From the keyboard, type Box. You can also use the box icon on the Solids toolbar. Now I'll enter the coordinates of the box using the values from the minimum and maximum coordinates on the spreadsheet. There's one, and that's the other. Now if I zoom extents, there we see the principal enclosing box. Now I'm ready to enter the data points. So I'll make the points layer current. In order to create data points, I'll use the point command. Before I do that though, I will change the setting that affects the display of points. The command from the keyboard is PD mode. However, it is simpler to go to the Format pull-down menu and select Point Style. This brings up the Point Style dialog box. There's a number of different options for displaying points. The default option displays a point as a pixel. A pixel is hard to see, so I will select this point style instead. Now I will enter the points. Typing point will only let you create a single point. To enter multiple points in a single command, you can select the point icon from the Draw toolbar. Or, from the Draw menu, select Point, then you see you have the option for single point or multiple point. I want to enter multiple points, so I'll select that. Now I'm prompted for coordinates. I will start by entering the points of the bottom curve. So I'll key in the values from the spreadsheet for each point on the bottom curve. Key in a coordinate and press Enter. Enter the next one, and so forth. There's the third point, the fourth, and finally the last point. Press Escape to exit the command. Next, I'll make the curves layer current. I'll also turn off the principal enclosing box. Now I'll use the spline tool to pass a curve through these points. In order to snap to these points, I will need to turn on an object snap. So I'll right-click OSnap to change the settings. I will turn on the object snap called Node. This will allow me to snap to a point. I will now select the Spline tool. I'm prompted for the first point. So, when I hover over a data point, you can see the node object snap. I will select this point, and then the others. I'm finished, so I'll press Enter to indicate that I'm done. Just to press Enter. This specifies a default tangency point. I will just press Enter here. This completes our first spline curve. At this point, I'll briefly review the process with the chine curve. Set the current layer to the points layer. Use the multiple point command. And enter the points listed in the spreadsheet. I skipped ahead and entered the points. Press Escape to end the point command. Now switch to the curves layer. Select the spline command and use the node object snap to select the points. Press Enter to stop selecting. Then press Enter to accept the default start tangent and enter again for the end tangent. Now repeat this process for the other curves. Once you've finished creating all of the data points and curves, your screen should look like this. Next, I'll open the Surfaces toolbar. I won't spend much time talking about the different kinds of surfaces, but I will point out that just as with solids, there are surface primitives. So you can use these different commands to quickly create different surfaces. In addition, there is a revolved surface command, which is similar to the revolve command for solids. Tabulated surface is similar to the extrude solid command. In this tutorial, I will use the ruled and edge surface commands. I'll use a ruled surface to create the bottom surface. We could also use this command for the side of the hull. However, for variety, I will use the edge surface command. So I'll start with the ruled surface. A ruled surface requires two objects that serve as rails in order to define the bounds of the surface. The location of where you select the object matters. To demonstrate this, I'll select the shear curve on this side, and then choose the opposite end of the chine curve. You can see we get this convoluted pattern. If I shade the view, it looks like the surface is crossed. So, whenever you use the ruled surface command, make sure you select points on the same side of both curves. Now I'll press undo, and then create the bottom of the hull. Select the ruled surface command, then select the bottom curve, and on the same side, the chine. Here is the surface, and it has a mesh density of 6. It is divided up into 6 segments. When I shade it, I get fairly good results, but if you look closely, you'll see gaps between the surface and the defining curve. You can control this mesh density by changing a setting called Surf Tab 1. Now I'll undo the surface command, and then type Surf Tab 1. You can see that the default for this is 6. If we make this a higher number, I'll enter 18, and then create another ruled surface. You see that the surface is now divided into 18 segments. The surface edges now match the curves a little better. Next, I'll create the surface between the shear and chine curves. However, at this point, it would be a little difficult to select the chine. This is why the bottom surface is on the temp layer. I'll activate the surfaces layer, and then freeze the temp layer. Now I can easily select the curve. This time, I'll use Edge Surface to create the surface. Edge Surface requires that you have 4 defining edges that form a closed loop. In this case, the stern, shear, bow, and chine curves. Notice that there are 2 different Surf Tabs, Surf Tab 1 and Surf Tab 2. I'll create a surface with these settings. So I'll select the 4 curves, and there you see, in one direction, I have a density of 6, and the other, 18. I'll undo this surface, and then modify the Surf Tab 2 variable. Type Surf Tab 2, and I'll make it 18 as well. Then I'll choose Edge Surf, and again, select the 4 curves. Now you see the surf density is 18 in both directions. At this point, I will close the Surfaces toolbar. I'll thaw the temp layer, select the bottom surface, and switch it to the Surfaces layer. The last step remaining is to mirror these 2 surfaces about the XZ plane. So I'll use the mirror command, select the 2 surfaces, and press enter. Now because of the way I built the model, I can choose the origin point as one point, and then turn on ortho mode to select the second point. Press enter to keep the source objects. So this finishes the hull. I'll turn off the curves layer and shade the view. This completes the tutorial on using splines and surfaces to model a hull form in AutoCAD.